Welcome to the DIY Honda Garage channel. The DTC P2118 refers to a throttle actuator current range performance problem, specifically affecting the Honda Odyssey models from 2011 to 2017. The throttle actuator is a critical component of the vehicle's electronic throttle control system, which regulates the airflow entering the engine based on input from the accelerator pedal. This system improves fuel efficiency and emissions by enabling precise control of engine performance. The throttle body is generally located between the air filter and the intake manifold in the engine compartment, often mounted on the engine itself. A malfunction detected via this error code indicates potential issues such as open circuits, electrical problems, or mechanical failures within the throttle control system. In attempting to address this trouble code, technicians should first utilize the HDS, Honda Diagnostic System, to retrieve and clear trouble codes and examine freeze frame data to better diagnose the issue. Subsequent procedures will involve checking connections and continuity to determine the root cause of the malfunction. The error code P2118 indicates a malfunction in the throttle actuator's current range or performance. The throttle actuator is responsible for controlling the engine's airflow by adjusting the throttle plate based on input from the accelerator pedal, thereby influencing the engine's power output and efficiency. This actuator operates as part of the electronic throttle control (ETC) system, which enhances the precision of the throttle response compared to traditional mechanical cables. In the Honda Odyssey, this component is situated in the engine compartment, typically mounted on the intake manifold. Its performance is crucial, as any irregularities could lead to reduced engine responsiveness or increased emissions. The Diagnostics Trouble Code, DTC, signifies that the vehicle's onboard computer has recognized a deviation from the expected performance levels. This could stem from several underlying causes, ranging from wiring issues to the actuator itself being faulty. Several possible causes may lead to the DTC P2118 being triggered. Electrical wiring faults are a primary concern, as damaged, loose, or corroded connections can disrupt communication between the throttle body and the powertrain control module, PCM, thereby impairing the throttle actuator's ability to function correctly. Furthermore, a faulty throttle body itself can directly result in performance issues, limiting the actuator's ability to adjust and regulate engine airflow. Another possible cause involves issues with the PCM, which coordinates various engine functions. If the PCM fails or operates inconsistently, the overall performance of the throttle actuator may be compromised. It's essential to methodically troubleshoot each of these potential issues to pinpoint the exact cause of the DTC, ensuring that proper and effective repairs can be carried out. Evaluating these components will be crucial in the overall diagnostics and repairing process. In the presence of DTC P2118, several symptoms may manifest within the vehicle's operation. One common symptom is reduced engine responsiveness. The driver may notice that the engine does not react as expected when the accelerator pedal is pressed, potentially resulting in unsafe driving conditions. This issue is directly associated with the throttle actuator's inability to control airflow correctly, which can significantly affect acceleration performance. Furthermore, the check engine light will likely illuminate on the dashboard, indicating to the driver that there is a problem requiring attention. Poor acceleration can also be symptomatic, as the engine struggles to gain speed, which might create difficulties, especially during overtaking or merging in traffic. Recognizing these symptoms early can provide a stronger basis for initiating an effective diagnostic and repair process. For the first troubleshooting step in diagnosing DTC P2118, start by ensuring the ignition switch is turned to the on second position. The HDS, Honda Diagnostics System, will be used to clear any existing DTCs, allowing for a fresh start in the diagnostic process. It's crucial to clear any previous error codes to prevent confusion during troubleshooting. Following this, slowly pressing the accelerator pedal to the floor is essential to observe whether any codes are re-triggered. This action tests the throttle actuator's range of motion and performance in a controlled manner, providing real-time data for the HDS to capture. After this initial assessment, the technician should check for any pending or confirmed DTCs that may reappear, specifically looking for DTC P2118 to determine if the issue continues. Observations made during this step form a foundational element for resolving the malfunction. The second step involves checking for any pending or confirmed diagnostic trouble codes, DTCs, using the HDS. If DTC P2118 remains indicated in the system, this points to an ongoing issue that requires further investigation. However, if the DTC is not present, this may indicate an intermittent failure, suggesting that the system appears to be operational at that moment, but other factors could still be at play. In this case, the technician should inspect for poor connections or loose terminals located at both the throttle body and the powertrain control module, PCM. Corrosion or loose connections can result in inconsistent signals being transmitted, thereby causing recurrent performance issues. It is crucial to diagnose whether the problem is a temporary fault or something that can lead to a more serious malfunction if left unresolved. For the third troubleshooting step, begin by turning the ignition switch to the lock 0 position to ensure that the vehicle's electrical systems are properly reset before proceeding further. Next, the technician should jump the SCS, service check signal, line with the HDS. This process is crucial for enabling the diagnostic tools to read data accurately and conduct further tests effectively. After preparing the diagnostic equipment, the technician should disconnect the throttle body 6P connector, which allows for isolated testing of individual components. This disconnection is necessary for assessing continuity and checking for any wiring issues that may exist between the throttle body and the PCM. Proper disconnection techniques must be followed to prevent damage to the connectors or wiring. In this fourth troubleshooting step, after disconnecting the throttle body 6P connector, the next action is to disconnect the PCM connector B, which has 49 pins. This step is essential to isolate the components and assess their individual functionalities. Following this, the technician is required to check for continuity between PCM connector terminal B33 and the throttle body 6P connector terminal number 3. A continuity test will confirm whether there is an uninterrupted electrical path between these two components. If continuity is present, it indicates that the wiring between the throttle actuator and the PCM is functioning correctly, suggesting that the issue lies elsewhere. However, if no continuity is detected, it points to an open circuit in the wiring, necessitating immediate attention to repair any faults in the wiring between the throttle body and the PCM. Addressing these potential wiring issues is critical to ensuring the electronic throttle control system operates effectively. For the fifth troubleshooting step, after successfully validating the continuity to the PCM connector terminal B33, the next operation is to disconnect PCM connector C, which also contains 49 pins. Similar to previous steps, this helps in isolating the specific circuits related to the throttle actuator. A continuity check will then be performed between throttle body 6P connector terminals number 1 and number 2. This check will help determine if there is an uninterrupted connection leading to the electronic throttle control motor's inputs and outputs. Proper electrical continuity is essential for ensuring the actuator can effectively adjust the throttle plate as directed by the PCM. Should the continuity test reveal no connection, this suggests potential wiring problems or faulty connections within the throttle body itself. Thus, immediate inspections of these wiring pads and connections are vital before moving on to concluding diagnostics. After the troubleshooting and necessary repairs have been performed based on the results gathered from the previous steps, moving on to the final repair verification is essential. Start by using the HDS to clear any DTCs from the vehicle's memory, ensuring that all previous fault codes are reset. Following this, the technician should conduct a test drive to assess the vehicle's performance under normal driving conditions. During the test drive, the technician should monitor the throttle response closely to confirm that it operates smoothly and without hesitation. Observations made during the test drive are crucial for establishing that the issue has been successfully rectified. Additionally, the system's functionality should be continuously confirmed through the HDS to ensure no new DTCs arise during operation. Successfully re-establishing the intended performance level and confirming no returning error codes is a culmination of effective diagnostics and successful repairs. Preventive maintenance is pivotal in ensuring the longevity and performance of the throttle actuator system in the Honda Odyssey. Regular inspection of electrical connections, especially around the throttle body and PCM, should be conducted to identify any signs of wear, corrosion, or loose terminals before they lead to performance issues. Cleaning the throttle body periodically can also make a significant difference in maintaining optimal airflow efficiency, thereby enhancing overall engine performance. It is advisable to check the accelerator pedal for responsiveness, ensuring that the connection between the pedal and the throttle actuator remains intact and responsive under various driving conditions. Implementing these preventive measures will help prevent recurrence of DTC P2118 and maintain smooth vehicle operations. Establishing a routine maintenance schedule will safeguard the electronic throttle control system against potential failures. In conclusion, effectively diagnosing and resolving DTC P2118 in the Honda Odyssey involves a systematic approach, starting from checking the ignition and utilizing the HDS for accurate diagnostics. Key components, including the throttle actuator, wiring, and PCM, play critical roles in engine performance and must be thoroughly assessed for continuity and functionality. If issues persist, carefully inspecting connectors and conducting specific continuity tests will help isolate problems that need addressing. Incorporating preventive maintenance practices will not only guard against the recurrence of such error codes, but also promote overall vehicle health and performance. Understanding the intricacies of the electronic throttle control system and its relevant components ensures that issues can be swiftly identified and resolved, leading to enhanced driving experiences. Please like and subscribe to the channel. See you next time.